from here. This one. Okay. So since last 2 days, can I have your attention? Since last 2 days, what you guys have learned? Can we have a brief? Anything? The drone application, Dr. Ankit may have delivered. Drone mapping, surveying, the protocols, digital sky maps. Okay, fly. Let me just go into the deeper physics of the drone flying again. Okay. The term deeper physics is not just flying. Merely flying anything wouldn't work. Okay, you need to fly in a controlled manner. Okay, that is the catch. So controlled manner means, let's suppose I have a drone and I want to take some snap or pictures at particular elevation. I want to go to at 10 feet height and I want to hover there and I want to take a picture on steady state. Those things will not be possible unless you know the physics of the problem or the trajectory planning. You have to go with certain speed. When it is about to reach at 10 feet, it should start decreasing its speed and it should remain hold at that particular position. So this whole thing falls under something called control framework. Okay. Also, the control framework, he might have introduced something called sensors. What are the sensors that are embedded in this particular drone? Any sensor? GPS. Anything else? Huh? Altitude sensor. Very good. Very good. So IMU sensor. Inertial measurement unit. So it talks about how the things are accelerating. Okay, last time, can you switch this off also? Maybe this one? Last one? ये वाला नहीं. Okay, good. Okay, last time we talked about velocity. So if the velocity is also changing with time, we call it as acceleration. How many of you knew this before in your 12th physics or somewhere, 8th, 9th, 10th physics? Huh? Okay, we will not go into that details. Okay. So quickly, since I have some slides also to show, so quickly let's see what things I have to show you guys. We'll talk about kinematics and dynamics today. Okay. So why it is essential, we will talk about in future slides. This, the drone definition you might have already come across, isn't it? So it's an unmanned aerial vehicle, any unmanned aerial vehicle, which autonomously or remotely is operated without human intervention. We call it as aerial drone. Take care. So drone could be fixed wing, could be rotatory wing, and could be fixed wing. Rotatory wing can also be subdivided into number of rotors that you have. So usually drones will have 4 rotors. We call these kind of drones are quad rotor. Okay. We have tricopters or quadcopters. Quad means 4. It's a Latin word. So bicopters are also there, tricopters, hexacopters. Okay. So based on their configuration, so this is quadcopters are more widely used, widely manufactured. Okay, why quadcopters are more preferable than your aircraft engines? Like, why it is more preferable? For simpler tasks, just pick and place, drop somewhere, do some job. So this is more of, we can get simplicity out of it, okay, without compromising on strength. Okay. So there is a term called VTOL, vertical takeoff and landing. All these drones falls under this category, VTOL. So somewhere you must have heard VTOL, vertical takeoff and landing. So all these drones and quadcopters falls under this category, VTOL category. Okay. This is a inbuilt, one of my students, I mean not one, there are 2-3 students, they have built it in-house. Obviously by procuring some of the components from market, from some of the websites. But assembling and testing, validation, those has been done in-house at our lab. At PDEU, we call it as Robotics and Drone Lab. We have dedicated robotics lab at PDEU. Okay. So you can see, you already might have come across these components, everyone. So if you see, so what components you can see? So these are propellers. So propellers are made up of those airfoils which makes them fly, okay, because of the pressure differences on top and the bottom surface of the propeller. Because of the pressure difference, please, it is able to fly, okay. Those are frames. So the one more thing I want to emphasize on, there are color coded frames. 2 are red and 1 are white. What could be the reason? Usually, any idea? Okay, let's suppose this is a drone, but this drone is flying very far from you, and you have a transmitter device, and you want to see or you want to operate, and you don't know which way is front and which one way is back. Okay, so it is a marker. Okay, it is a marker that this red thing should be in back and white should be in the front. It will be a marker. Let's suppose wherever it is flying, so when you want to go forward, okay, you see the red frames, so red frame should be pointing backward and white frame should be pointing front, and that way you can actually navigate your things. This is one of the markers. Okay, here there are no markers, or there are. Any guesses? Anyone? If you switch it on, I don't know, there is a marker also here, but you cannot see it now. Why? When you switch it on, there are 2 LEDs. One is red and one is green. So red one could be your back and green one should be your front. So this way you can demarcate things. Things are there, but we have to critically think, critically see things. Okay, things are there. So engineering is all about making your life easy. Okay. If you go into more details, you will start loving the engineering subjects. Okay. But again, you have to deal with the mathematics. You cannot get away with the mathematics. I'll not show much mathematics. I'll try not to show much of the mathematics or equation, because there are very large band of students that are sitting here. Okay. Okay, what else? Okay, propellers ho gaya, and then you have a battery beneath it, and battery is connected with some sort of board. We call it as power distribution board. The power distribution board is sort of making a circuit in order to distribute your current to all your motors that are attached to the frame. Fine? It is sort of circuit. Okay, on top of it there is something called flight controller, which is the brain of this particular guy, brain. Okay, any machine, any intelligent machine. So let me just go back once, slightly step down. So any intelligent machine should have 3 components. So this should be your takeaway from this particular class. Okay, at least this 3 takeaways. I mean, 1 takeaway from this particular class. Any intelligent machine should have 3 things. Must have 3 things. First, they should sense the environment. First thing, any intelligent being. We, as a human, also we have what we do first. We sense. We sense through our 5 senses. Although there are more senses if you go into details, but 5 are more common. Okay, touch, seeing, what else? Hearing, smell. So those things we are getting aware of the environment. Okay, what is happening around me. So similarly, it will have some sort of sensors that will make this guy aware of the environment. What are those sensors? IMU. What else? GPS. What else? Camera. What else? Altitude sensors, pressure sensor. Anything else? Gyroscope. So altitude sensor will tell about the height. Gyroscope will tell about the orientation. Okay, ऐसे झुका हुआ है, इधर झुका हुआ है, किधर झुका हुआ है. It will tell how much theta, phi, psi. So the orientation will also be. I want to know. So currently I am up straight. Okay. I could fall down, but my brain should, when I am falling down, what my brain tells, there is some sort of sensing. So because of evolution, we have a sensor. I am falling down. So what I have to do? Next thing, what I have to do? I have to use my brain. Okay. So the first thing is sense your environment, intelligent being. Second thing is process through your brain. Process. So second, intelligent being, what secondly it will do? It will process of that after collecting data, what you should do. Okay, let's suppose I have seen apple behind Andrew. Okay, so I took the data with that apple. What should I do? My brain should tell. Okay, let's suppose I am here. If I am hungry, so my brain will tell, okay, you are hungry. Okay. So now this is an apple. Just process it, and it will tell your brain that this is an apple. Okay. Now what is the third thing? Intelligent being what will do? Act, respond based on the processing. So first thing is sensing, second is processing, third thing is acting or responding. Very good. So any intelligent robot or anything you want to build, it should have 3 components: sense, process, and respond. Okay. So my brain will tell, okay, there is an apple, nice apple. So you should reach upon that. So how you will reach? How will you respond? Through actuating your muscle. Okay, हाथ बढ़ाएंगे, and I will grab it and I will eat it or whatever. Or if I don't want this guy, I can do anything. I mean, it depends upon your brain. Okay, you can do anything. Processing doesn't mean you are doing good or bad. Okay, so it's an evolution. What you want to do with that apple? You want to throw it or you want to eat it? It's up to your brain. Okay, again. So yes, for making any intelligent device, you should make sure that you should collectively put 3 things: some sensors that will sense, some processor which is your flight controller. Here in this case, Pixoc flight controller is an open source hardware. Okay, it is a semiconductor device. Okay, which can do something, which can do some processing. Okay, now your question must be, okay, we are human beings, we are alive and we can think. How these non-living things have a processing power? How come? Can somebody tell me? How a non-living thing starts thinking? बताइए. We have a brain, we have neurons. Huh? Yes, please sit. This is a non-living thing. Let's suppose pen. I cannot even think. I cannot even think that this pen start thinking. But now we can. We have something called, it's a non-living being, but it starts thinking. Never ever wondered that how it starts thinking? Anyone? This is actually a milestone that human achieved. Once we gave intelligence to that particular guy, we actually, our human mankind evolution has surpassed many years. We have reached to Mars, Moon, because of that. Because the non-living thing starts thinking. How come a non-living thing starts thinking? Any guesses? I mean, कभी सोचा नहीं. You use washing machines, it's intelligent. You use television also. You do something and starts giving recommendation, Netflix, and starts doing something. And why it is so? Your computers, you interact with them, starts thinking. Actually, this should be taught first. Any guesses? And this should also be a takeaway from this particular class, my class at least. ऐसा क्या है इसमें? सोचना शुरू कर दिया. Okay, so let me give you an answer. Any guesses? Wrong answer चलेगा. Andrew, anyone? Anything? ऐसा क्या है इसमें?
Not sure.
Not sure. Your mobile is also an intelligent device. How it starts thinking? You calculate, Brain, how you make that architecture out of non-living thing? You do something and it starts thinking rationally. If you do 3 plus 3, it will do. Calculator, you open calculator and it will do. How? Never ever thought? So this is why the real education comes. You start. So this, any of my classes, I don't want you to actually understand this. Actually, I want you guys to let you think that you start thinking critically, everything. You start questioning. You guys don't ask questions. Actually, that is the problem. Okay? I mean, I think our culture is set like this. We are not encouraged to ask questions. Okay? In my childhood also, when I was in school, I was also being suppressed, being after questioning. Okay, that is in our culture, but that we should leave behind. Okay, we should ask questions. Why it is so? Why not? It's in our culture. But anyways, so one takeaway should be from this class is also start questioning everything that comes into your mind. Why this? Why not this? Why I am sitting here? You should also ask yourself, why are you here? Why drone technology? Why German? Okay, so much of the philosophy. Okay, now let me answer this particular thing. So there is something called transistors. So with the advent of this transistor, so what are transistors? So transistors are made up of, so it's sort of diodes. It's a diode. It's a logic devices. Okay, logic devices means electron will flow from one end and there will be a valve or there will be a logic gate, and based on something it will either pass or not pass. So something will come and it will not go. So you will have logic gates develop. And what is the basis of that? So if you sit in semiconductor classes, they will tell you about something about p-n junction or doping. Okay, semiconductors have a nice property. Okay, so what they allow, so semiconductors, if you dope it properly with some sort of germanium or something, even I am not that particular expert, but yes, if you do something out of it, so electron will start behaving in a logical manner. Okay, 2 electrons will go, it will add. or do something. One electron will come and one will not go. Okay, nothing will come and something will go. Some sort of logic devices starts developing, and if you make things complex circuits out of it, it will start thinking rationally, mathematically. Even these days you can actually integrate, differentiate, you can do lots of mathematics with only this architecture, and from there the intelligence involves, the crude intelligence of non-living things. That is the basis. Okay, at least something we'll take from this class.
Yes.
Something, है ना? ठीक है. So now we are done with. So we have the brain with those transistors, and that is another course. If you want to learn how the intelligence comes, you have to do another engineering, VLSI or electronics engineering. You have to do the whole engineering. It's a separate domain. It's a whole full exercise. So just being aware of that, now we'll come to here. So flight controllers, now we have a brain. Okay, what else? Now this brain will have to do something. No, it will calculate using sensors how much height you have attained. Okay, it will start telling your motors that this much speed you have to spin, 5 meters per second or 5 radian per second, 10 radian per second, based on their sensor data. Okay, then only it can accurately reach at 10 feet and start clicking your marriage pictures. Okay. Okay, before that you will have something called ESC. Anybody? Last class you must have come across ESC. Any guesses? So ESC is something that will control your rotation of your, or control the current inside your motor. How much speed you have to run. Electronic controller, to be precise, we call it electronics controller. So ESCs will, your flight controller will send a signal to ESC how much you have to spin your rotor or that particular brushless motor. So there are lots of categories of motors. Brushless motors are widely used because of its high torque, high RPM, and on top of it, through the coupler, we mount it through the propellers, which can now rotate, and then because of physics, it will move up. Fine. What else we can see? Okay. So this is not fully autonomous. No, this is not fully intelligent. So what we should do? I have to tell the mind that okay, now this much height you have to go, this much left you have to go, this much right you have to go. You have to do it with using transmitter, radio transmitter. By the way, ESC full form is electronic speed controller. Okay? It will decide how much fast your brushless motor could spin. Okay, transmitter, through transmitter I can give signal while moving up the jack left and right. I'll give the signal, okay, now you have to lift up right, you have to go left, back, up, down, everything, and that will be received by the receiver also. Okay. In general, drones are a mechatronic device. It is a beautiful amalgamation of mechanical, because of the physics, electronics and computer science. Okay, it's a beautiful amalgamation because you need to tell the controller in his language, or we call it as programming. We will program it. We are also programmed. In what manner? We humans are also programmed. Can somebody tell me some examples? Our DNAs are coded with programs. Okay. Can somebody tell me what sort of program? Any program. When we are hungry, some something will signal will tell, automatically we'll start eating. We'll find someone lovely, we can approach him, we can go there. Maybe I like to travel. Our hobbies, we are programmed for every being, everything. Okay. Everywhere it's programming, it's embedded. Okay, this is the whole architecture, I mean overall frame, and this is in-house we have developed. This is self-assembled quadrotor drone at Robotics Lab, our PDU. A few of my students have developed this. So you can see this is a GIF of when I increase the transmitter jack, so the motor starts spinning. Okay. Now it is not lifting. Why it is not lifting? Motor is running. Motor is running, but it is not lifting. Huh? Tell me. Very good. Very nice. What is your name? Very nice. Very nice, Kevin. Because there are no propellers. Even though you spin motors at any number of speed, any radians per second, it will not lift, because lifting of surface is done using airfoils. Because of the pressure difference, there is no pressure difference right now. So once I connect propeller, this is pre-stage of making drone. Okay. Critically you think, thank you. Obviously, this is obvious. There are no propellers. That is why it is not lifting, even though your motors are running at high RPMs. Okay, this is a Pixoc controller. This is GPS, motors are running. This is battery. Okay, fine, let's see. Okay, so we are currently, in our lab, we are in a process to develop. So this we are doing using either our mobile or the transmitter. Okay, now we are in a process to fully making it fully autonomous. What does it mean? You are at your own. You see, you think, you decide whatever you want to do and you do it. We call it as fully autonomous. Now it's like my bacha. Okay, now you go there. Do whatever you want, but in certain limits. Okay, now why it is helpful, autonomous? Humans, I mean, we don't want to intervene for every task. Okay, I want to sit down, I just want to program it. Okay, what program? Okay, so the program here is from National Skill Academy. Pick this thing, fly with this much RPM or with this much speed, and go to maybe next metro station and drop this particular payload there and come back. I'll write a program and it will do automatically. But it will require more sensors, more processing, more intelligence, more complexity. So the the black one, we are developing fully autonomous right now. So it will go from one place, particular A place, to B. It will go there autonomously, land, take some pictures, come back and land again. And in between all, trees comes, what it will do? It will look out, because it will have a camera. Okay, it will look out, oh, there is a tree. Okay, now what to do? You change your course accordingly. So we will train him using machine learning, artificial intelligence we will give. That is another engineering. It's a whole. So these days anything is not one engineering. It's amalgamation of everything. Okay, those days are gone. A separate engineering or separate subjects are fine to me. But these days everything is a amalgamation, beautiful combination of everything. Then only you will have complex things. Okay, China has a mission to make 10 million robots. Yesterday I was reading 10 million robots, household robots, till 2024, 2040. Okay, because of their aging population, they need someone to help them. Now we will not be needing nurses. Getting where I am going? And that is why drone technology or robotics or anything is important. You will be replaceable sooner or later. Yes, I am telling you, you both. You guys are nurse right now? Just count the days. I'm telling it is there. It is coming. Sooner or later it is coming. Humans will do nothing. We'll just, I don't know what we do. Then we'll lose the purpose. We'll lose the meaning. I don't know. I mean, this is getting philosophical. This class is becoming philosophical, more of drone technology. But it is, eventually everything is philosophy. Science is also a philosophy. Science actually evolved from philosophy. Philosophy is what? Huh. Mind, language, and human behavior, sort of. Okay, it seeks answers critically. And that is why I am coming. So we will not be needing nurses. Nurses chhodiye, we will not be needing doctors. Da Vinci robot, have you heard? Internet aa raha hai? Internet is there? I don't know. So Da Vinci robot, which can actually do surgery. Humans can make mistake. Robots, I will train him. It will cut through stitch, everything it will do. It is no more a future. It has come. Self-driving cars. If you go in US, India, I can understand, it will take time. US, if you call Uber, no human will come. A car will come, appear with driverless, and you will sit and it will go. Handle ऐसे से करके आप कुछ नहीं करना. Okay, what else? What other job you are thinking? Tell me. Nurse out of scope, drivers out of scope, doctors. Tell me next.
Students.
Tell me. Huh? Household be it's near future. I mean, humanoid robots. You know, human-like robots. You start prepared. What do you think? Your metros and aircrafts, pilot runs? No, they are just sitting there. Something happens, they will override it. Nowadays, everything is automated. Every action of your plane is being decided by computers. Pilots are merely there just to be there. If something getting wrong, you can override it. That's all. He is doing nothing there. I'm telling you, metro drivers, everything is computer. He is just sitting there just to override everything if something goes wrong. Even if someone comes on track, it will automatically stop. He knows. Nothing you have to do. Cameras will be there. It will recognize using algorithms, image processing algorithms. Okay, this is a human. We have to stop it. Everything is coded. I don't know what humans will do. What I am thinking. So what do you think? Chaliye, we'll talk about it, because this is actually we need to talk. We do not talk about these things. We talk about technology, but we don't talk about purpose. Maybe 5 minutes we'll take.
So, sir, I mean, just I may not be mechanical or technical in approach, but how will this affect faith in the human society?
Yes.
Faith system.
Faith system.
Yeah.
Definitely.
The belief system.
Belief system will also probably, what I am thinking, in my opinion, belief systems has already shifted. Okay, people are become more scientific these days. Okay, they are critically thinking things in a way that our ancestors never thought. Okay, definitely it will. But okay, again, there is a research. We are hardwired with what you say, our culture, our religion, our hardware. We are hardwired. Human brain is very complex. Okay, philosophy. How many of you are philosophy background, or maybe philosophy or psychology? Anyone from here? It's a beautiful I don't know why it falls under arts. It is actually science, philosophy. It asks questions about mind, humans, critical thinking, language. And actually science developed from this philosophy, asking questions. Okay, why not this? Why sun is always rising from east and always sets down in the west? Why? Humans starts asking questions. That is why we are here. But again, my whole question is, what would be the purpose of human then, when everything is automated? What we will be doing? I don't want to demotivate it, but yes, we have to think about it. Now, in my opinion, I mean, this could be one of the ways we humans can, what you can say, self lie, or maybe I don't have the words. अपने आप को cheat कर सकता है, in a way that everything will be done by robots, and we have to pursue our passion. What do you want to do actually? If you don't want to, let's suppose you have interest in what? Classical dance. Was very good. So she may pursue in classical dance. What wakes her awake? What's your hobby? Sona. Cooking. Okay. So she might be cooking everything. What's yours? Drawing. आप drawing करते रहिए दिन भर. आप traveling. So he can travel. He will explore the world. Andrew, what do you want to do?
I will try to research on society and.
You can do that also. Robots will be there to assist you.
That.
What do you want to do? Singing. आप singing कीजिए. Yes. Keep singing. Make YouTube videos. Yes. You don't have to do. Okay. Now the question arises. Okay, singing can done by AI. Then why humans? And AI can also sing and upload its video, and it can have subscriber, and it can have millions view. Then why she will sing? Now the question one level above. Now humans will seek. So there will be AIs everywhere. Everywhere it's robot. But humans will seek humanly touch only by, if you see there is a painting which is actually done by human. When there is a singing which is actually sung by some human. AIs are everywhere. So that is the stage we have to come. I mean, what I am thinking. But again, the purpose of the whole humanity would be to pursue your passion, it seems. Now somebody will tell, okay, sir, paisa. The money will be obsolete, obviously. Everything you will get, right? So your robot, your farming robot. Yes. Please come. Ana, andar. So somebody will tell, okay, खाना. क्या बोलते हैं आप खाने को मलयालम में? Food. नहीं. भोजनम. भक्षणम. Okay. तो भक्षणम कहाँ से आएगा? So Bhakshanam will be prepared by your robots. He will go to farmland, it will plow, it will, no, she's laughing. It is a reality. It will go to your farmland, it will plow, it will put a seed, it will irrigate, it will take images, all sorts of things it will do. It will pluck also, and it will come to you and spoon में लेके आपको खाना भी खिलाएगा. This is a reality. So again, maybe for the current human, it is to develop those robots, current. But once these robots are developed, or what will happen, one more step I can go ahead, a mother robot will be created. This is not hypothetical. Mother robot will be created. She will give birth, not actual birth, but she will create. Mother robot will create those tiny robots, it will do all sorts of things, and it will keep on doing till you have the energy to do. However, it is too far, but yes, it will come. Humans will not have to follow money anymore. You have to follow your passion, whatever makes you awake, whatever you want to feel like doing. And that is what my perception is we are going towards. This is sort of philosophical, but yes, I thought I could deliver this also. That should be your takeaway also. Why I am doing this actually. ठीक है? नहीं, अच्छा नहीं लग रहा है इसको.
So just
Huh.
asking,
Huh.
since I'm from arts background, see, robots will not have gender. Will they have gender? No, right?
Gender won't be having any meaning as
That
such.
will not have any relevance.
Yes,
in that
there is
sense.
relevance.
So what would we think of such a world when the kind
That is
of-
very bleak, very
Yeah.
very dull.
very-
So yes, definitely, I am coming to that. Human touch. We need that time. We will realize that human touch we'll need. We want to actually talk to you, talk to her, talk to someone. Maybe we want a human touch. We want to have human interactions. That is sooner. That will be sooner than you think. You know, there is a research. Humans are getting lonely. You keep on scrolling Instagrams. You follow your friends on Instagram, but you don't follow in real time. But actually, humans will realize sooner or later. We'll have to interact ourselves, and that is how we have evolved. Actually, humans are social. So if you are no more social, we are obsolete. I mean, will not be in the race. We have to be social. There is a lot to go into details, but obviously I have to come to drone technology again. Okay. But these things usually when I teach, I want you guys to be aware of these things. Okay. Why I'm doing this actually. ठीक है, चलिए. Next. So this I have discussed, right? So there is an airfoil. It needs to rush. The upper fluid element has to rush, and this will go with same speed. Rushing will allow the pressure to decrease, pressure to increase, and it will give lift. But this is not entirely correct. So if you go into the deep details of the engineering, this is actually just somewhere theory came, but it is not entirely correct. This is only correct if the flow is laminar, flow is inviscid, irrotational, those things. But if in reality flows are very complex. Okay, in reality something called circulation theory of lift works. So in NASA website, if you go, there is something called circulation theory, and which is not advisable. I mean, which I will not talk about it for this particular audience. However, you should keep in mind there is some other theory called circulation theory of lift, which actually lifts things. Okay, not what I told. This is not entirely correct. Okay. Okay, again, there are types of UAVs: single rotor, multi rotors, 2, 3, 4, 5, 6. This is widely used. We call it as quad rotor. Fixed wings are also there. These are moving wings. These are fixed wings, and we have hybrid things also, which can take a use of both. Fixed wing also, once it lifts off, it goes. These kind of things are used in defense. Obviously, applications they might have already taught you. So, is there any break in between, or yes? Okay, break lena chahiye. Humans, yeah, that is also. I mean, we need breaks. We need food. We need light to work. Robots, no break, no light. They will keep on doing. Okay. That is why humans are very fragile, and we are so tiny. If we talk in terms of our universe, we just keep seeking our purpose. but we don't find anyone. Or you guys have found out your purpose? Not yet. ठीक है. So how much time will take a break? 10 minutes. ठीक है, 10 minutes will come back. ठीक है. हाँ, ब्रेक का है कितने बजे? Now. ठीक है. So we'll take a break and we'll come back and we'll start with something called, yes, something we'll start with this particular question. Okay, before going to the break, please, one open-ended question so that you can also discuss during break. You must have seen that, or you must have been told by other professors that two of the wings rotate in counterclockwise and two in clockwise. Huh?
Yes.
Why is it so? Have you asked them? Why, sir? Why not? Why didn't you ask? So this is the problem. This is the takeaway you should take. You should ask questions. Sir, you told me two of the wings will rotate in one direction, two in another. They must have told you.
Yes.
Huh?
Yes.
हाँ, okay. Just 1 minute. हाँ, है ना? याद आ रहा है आप लोग को? Yes. Two of the wings were rotating in one direction, another two in different directions. Did they tell you?
Yes.
हाँ. And did you ask why? No. हाँ, but how come stability? But can you elaborate? That is the question you should ask. Everything. Even I am not. Even I don't know most of the things. I'm also learning. Every day I learn something. I'm not God, so I'm expert. But even I don't know everything. ठीक है? But I'll ask questions. How? Why? To you also and myself also. Keep questioning. चलिए. With this we'll have a break.
Good, sir.
Everyone got settled down? Okay. Please keep it. Yes. Okay, now let me begin with what we have left behind before the break. Okay. So before the break, we have an open-ended question that why do these rotors, why can't we rotate these rotors, however, the same speed, with same rotation, but in different directions? What if I rotate everything in same direction? What will happen? Any guesses?
Unbalanced torque.
What will happen?
Unbalanced torque. It will experience
Yes. What is the meaning of torque?
the action and force also to rotate.
Okay. I mean force, if the force is acting offset to some axis, it will have a tendency to rotate something. Okay. So, see, please pay attention. If at all, ध्यान दीजिए यहाँ पे, if at all, in this particular pen, there will be a center of mass. Your body will have a center of mass. All your, so if at all you are a point mass, your body's overall mass could be thought of concentrated on one point. Okay, and that is its center of mass. So if I put a force on center of mass, it will just translate. If I put a force alongside the center of mass, what it will happen? It will have a tendency to rotate. Please. Please sit down. I will give one example. Okay, बारिश होने लगी. I will. Okay, sound that one. Okay. I will give one example. ठीक है? In order to understand this, why all these rotors should not be rotated in one direction. Let's suppose you have, how many of you have seen helicopters? Helicopters. Okay. In helicopter, please pay attention. Shh. Please pay attention. No talking. Please bear with me for a few minutes, and obviously will not take much time. Okay. So helicopter will have one propeller which is rotating. Okay. And you will see these helicopters will have additional rotors on tail. We call it as tail rotors. The moment you know why the tail rotors are here, you will understand this concept. Let's suppose a hypothetical situation. What if the tail rotor is not there, or it has malfunctioned? You know what will happen? Now if it rotates, what will happen? No, it will not crash eventually. What will happen exactly? If your propeller is rotating in one direction, your body will rotate in other direction. You know why? In order to conserve its angular momentum. I don't want to throw these bigger words at you, but yes, this is because the system wants to conserve its angular momentum. Not only angular momentum, it wants to, any body wants to conserve its momentum. Now you will ask, what is momentum, what is angular momentum? So before that, let me tell you, this whole universe, this whole universe works on three principles. Okay, one is conservation of mass, another is conservation of energy. Who told? Very good. So how energy is conserved? It just changes its phase. Overall energy in this universe is constant. Similarly, overall mass in this universe is constant. The third rule is conservation of momentum. Overall momentum on a body will be conserved. So forget about that. Let me give you one GIF so that it will be clear. So one of the tail rotors has been malfunctioned. See what's happening. The propeller is rotating, but its whole body keeps on rotating other way around. Okay. So in order to counter that body rotation, we have additional tail rotors in order to counter that. Okay. Now come to this thing. What if all rotors are rotating in same direction? What will happen? It will go up. Obviously, eventually it will go up, but it will start. So if things are rotating clockwise, it will start rotating anti-clockwise, but it will go up. But it is not desirable. Why? Obviously, you need to take, let's suppose you need to take some marriage picture. You need to be stable. You don't want to rotate and take pictures, right, every time. You need to be stable. So in order to get stability, what we do, we rotate two propellers in one direction, another two in same direction, which conserves its angular momentum. Okay. So one more example I can give you, conservation of momentum. So have you ever fired a gun, maybe in some mela or somewhere? What happens when you fire a gun? The bullet goes in this direction and your hand pushes back. Why it happens? Okay, so initially the momentum of bullet and mass is 0, and your bullet acquires some momentum. In order to act that, you have to go back, because its whole thing is a system. Okay, so this is a universal law everywhere you will find. So this is the physics behind angular momentum conservation or linear momentum conservation. Okay, maybe this could be way ahead what you guys are currently, but yes, keep in mind that because of angular momentum conservation, we need to rotate these things in two directions. Otherwise, it will keep on rotating itself. Because of, you can see in this the rotor malfunctioned and it starts rotating, and it actually happened in which it went for a rescue operation, and somehow the tail rotor malfunctioned and it crashed. Same thing. Okay, I hope they might have told you, previous tutors might have taught you about these three motions, yaw, pitch and roll. You understood? Okay, so the roll, what is the roll motion? Okay, before roll motion, we need to tell the coordinate system. Okay, coordinate axis. Okay, let's suppose this is your aircraft. Okay, let's suppose this is your aircraft. Okay. So the forward thing is your x-axis always. This is the convention. This is your x-axis. Okay, and right wing, always remember, this is the convention. Right wing will be your y-axis. X-axis will be forward, y-axis will be right wing. And what about z-axis? Will be downward, always. So x, y, z. Okay, now listen this. Now this convention you have understood: x forward direction, y right wing side, and z down, x, y, z. Okay, so if your aircraft is rotating along x-axis, if your aircraft is rotating along x-axis, we call this as roll. Make sense? Rotating along x-axis, along x-axis, along x-axis. Okay. Now your aircraft, if your aircraft is rotating along y-axis, y is where? We call this pitch, pitching moment. This is roll. Everybody do this. चलिए exercise करते हैं. ये कम से कम take away लेके चलते हैं. Everyone. This is my aircraft. This is my convention. This one. ठीक है. Index finger forward. This middle finger right. नहीं आपका ऐसे हो जा रहा है. ठीक है. थोड़ा सा ध्यान दीजिए. ये इंडेक्स फिंगर तुम ऐसे कीजिए. थैंक यू. डाउन कीजिए इसको. यस, ये वाला डाउन. योर थंब शुड बी डाउन. थैंक यू. एंड मिडिल फिंगर राइट हैंड साइड. दैट्स ऑल. क्लियर? अभी हो गया. आपका भी हो गया. आपका दोनों ऐसे जा रहा है. ठीक है. ठीक है. कैन यू डू दिस? वेरी गुड. थैंक यू. पीछे से आपका. सो एटलीस्ट ये छोटे छोटे टेकअवेज होने चाहिए इस क्लास से. ऑब्वियसली मैं आपको यहाँ पे I cannot do all the mathematics here, but yes, these takeaways will keep you remember these things a long time. ठीक है. So yes, you means x-axis. Everyone you. Yes. Thank you. And then thumbs down is the z-axis, and point your middle finger right hand side is your y-axis. So x, y, and z. Now let's do the exercise for rolling. So rolling कैसे होगा? Yes, you tell me. Rolling कीजिए. ठीक है. This is a fun exercise. Obviously, this is teaching as well. So this is rolling. So when your aircraft does this, we call this rolling. Not only aircrafts. Yes, we do are developing underwater vehicle as well. पानी के अंदर चलता है. I'll also show some pictures of that as well. We have an underwater robotic vehicle also we are developing in our lab. ठीक है. And their dynamics is similar to what aircraft's dynamics is, except there is air and it is under water. It is much difficult. Obviously, electronics part पानी के अंदर should be more isolated. Okay, so this is your roll, everyone. Yes. Okay, now pitch. Pitch. हाँ, pitch कैसे करेंगे? Fixing this. See, लाभ कर रही है, ऐसे से कर रही है. ठीक है. And what about roll? Sorry, roll तो हो गया. Roll, pitch and your z axis. हाँ, z axis. हो रहा है? सबका हो रहा है? आज एक एक्सरसाइज भी हो गया आपका. ठीक है, मजा आया? अभी ऑब्वियसली लर्निंग शुड बी फन, अदरवाइज कीप्स आई डोंट वांट कीप थिंग्स बोरिंग. ठीक है, फन होता रहना चाहिए. लर्निंग तो होता रहेगा. लर्निंग विल, आई मीन, till you are on deathbed you will learn something. This is again philosophy lesson. नहीं, yes, no, you keep on learning everything till you die. So yes, so ये तीन चीज हो गया, right? Your pitch and roll. So now we'll see here. Let's suppose this is forward, है ना? So forward motion, this is forward motion, this is sway. Very good. Sway, surge, sway, surge and heave. Did we tell you? Okay, maybe this is a nomenclature used for underwater vehicles, not here. So this is X motion or longitudinal motion, lateral motion and down motion. ठीक है? Okay, please pay attention again. So this is X direction motion, and along that X axis, if you do this, we call this roll. Okay? Okay. Then lateral motion, sideways. Sometimes your aircraft sideways goes. Okay. This sideways axis, if you roll, if you do this, we call this pitch. So pitching is important for takeoff and landing. Pitching is important for takeoff and landing for aircrafts, right? Okay. What about Z axis is down, and if you rotate this way, we call this yaw. Okay, at least these three things you should keep in mind. Yaw. ठीक है? Okay. So same thing has been shown in this figure as well. Okay, this also you might have been taught. Okay, how to roll actually. If everything rotates at same RPM, please pay attention. Nurses, if you rotate everything at same RPM, it will just lift. Obviously in different directions, that is another part, but yes, same RPM, rotations per minute or revolutions per minute, it will lift up. Okay, what if I want to roll things? If I want to roll things, what I have to do? I have to keep these two right hand side rotors speed up and left hand two sides slow down with same speed. Omega 1 same, omega 2, but omega 1 is lesser than omega 2. Then what will happen? A rolling moment will come. Okay, this is what has been depicted in this drone. Obviously this is X configuration. X means this is X type rotor. There is one more plus type as well. So this is plus type. So this is usually used. This is X type. So see, these two right hand side, if you increase the speed, makes sense? Right hand side you increase the speed, and left hand side you keep things still or maybe similar speed, then it has a tendency to roll. Make sense? इन दोनों का स्पीड बढ़ाएंगे, it has tendency to roll. Okay, next, what if I change the speed of front two rotors? What will happen? Pitch. So based on those movements, I can actually control things now. I can do rolling also, pitching also. Okay, what about this? So these two things which I increase, okay, overall in your sense it has, if I increase these two things, overall the yaw moment creates additional yaw moments, and in order to conserve the angular momentum, it will rotate or it will yaw. These three things you have to keep in mind. How you are going to roll, how you are going to pitch and yaw things by handling your individual rotors. आ रहा है समझ में? Yes, no? समझने को मलयालम में क्या बोलते हैं? Oh, sorry, I cannot. ठीक है. Understand, हाँ. Will not talk much, but I will move into, there is something called, now much deeper physics. There is something called kinematics and dynamics. Any dynamical system, any moving system can be analyzed using two frameworks. We call it as kinematics and dynamics. Okay, these two words at least you remember. Kinematics and dynamics. ठीक है? Now let's understand what is kinematics. Okay, in order to understand kinematics, let me ask you, how many of you have played carom board? Carom board? Everyone? Very good. So what you do in carom, usually, you just strike through striker and you hit the coin in certain angle, and it has to traverse through certain way path, and it has to go into the slot. This is the way you keep in mind. So kinematics part is also similar, something like this. You are not worried about the forces acting on it, rather you are worried more about the path it is going. Kinematics part is all about, it is the geometrical aspect of motion. Where it is going. It is going to the pocket or not. It is going to this angle or not. That angle or not. Or maybe this orientation or not. Everything that talks about this thing, geometrical aspect, we call this kinematics. And that is necessary. Why? So I need to know the orientation of this at every time. Okay, when you start flying it, obviously it can go something like this, that, that. So every time you need to know the orientation of this. आड़ा है, तिरछा है, कैसा है, नहीं है, वो सबका पता रहना चाहिए मुझे, information. I need to know. ठीक है? And that will be taken care by the kinematics. ठीक है? The study of kinematics is, that is why important. Okay. How it is done? Now the mathematics will come. ठीक है? Okay, the next, the other keyword what I told, kinematics and dynamics. Okay, now what is dynamics? Now dynamics will ask questions about how much force you have put on and this much acceleration I have gone through. Okay, there are two aspects. It means kinematics will tell you how it is moving, this way, that way, and dynamics will tell why it is moving. So it is moving because I have given thrust on this much amount of thrust, this much amount of force, and it has gone to this acceleration. Okay? So these two things are different, and which is you talk about any physics, you have to know about kinematics and dynamics in order to understand the physics of this thing. You can say you have to know. Okay? So in kinematics, in order to understand the orientation and the position of this thing, we need to fix something. We call this as reference frames. Okay, now the frames will come into picture. Maybe slightly, let me understand. Okay, now do one thing. Let's do this exercise. Please pay attention here. Let's suppose this is my x-axis, this corner. ध्यान दीजिए. This corner is my x-axis. y axis and z axis. ठीक है? And this corner is my origin. Origin means 0, 0, 0. And I started from here. I started from here and I walked in x axis 3 meters, let's suppose. Let's suppose 1, 2, 3. Now what is my position? Can somebody tell me? In terms of coordinates. 3, 0, 0. Very good. What is your name? Romeo. Very good. I mean, you are appreciating. So now I have moved 3 meters in x axis. Now you can locate my position by saying that now it is at 3, 0, 0. What if I jump 2 meters? I mean, I fly 2 meters. Now from here itself, I fly 2 meters. Or to be very simple, I walk 2 meters in y axis. Now what is my position? 3, 2 and z 0. Very good. Now next thing is, if I stay on this table, if I keep myself on this table, and this table height is 1 meter. Now what is my position? 3, 2, 1. Make sense? So origin will tell you what is your initial position, and that is my reference frame, which is 0, 0, 0. And now I am sitting at 3, 2, 1 along with my body fixed frame. So one frame is along with me and one frame is sitting there. So everything is in reference now. Now from keeping this reference, I can tell where am I every time, right? So this is just the translation motion, x, y, z. It doesn't talk about, okay, now the same exercise. I am here, 0, 0, 0. I displace myself 3 meters apart, but also what I did, I rotated myself. I rotated myself this way. Then I moved 2 meters here and I rotated also again this way somehow. And then I sit on this table 1 meter apart and rotated again. Now can you tell me the difference? If I know only 3, 2, 1, can you tell me the difference whether I have rotated? No, cannot. So for rotation, in order to know what exactly my state is, not only I need 3, 2, 1, I also need 3 more components. That is my theta, phi and psi. Then only I will theta, how much I have rotated this way, how much I have rotated this way, and how much rotated this way. So these 6 components, if I would be knowing, I would completely tell my drone, it is, yes, drone is it at 3, 2, 1 with this theta 30 degree, 45 degree and 75 degree. Then only completely specify my drone position and orientation. Sense at least something? If I would be an egg, then my rotation wouldn't mean anything, right? If I would be an egg or a round ball, even if it rotates, it's okay, doesn't matter. But if this thing rotates, it matters a lot, because this is asymmetric body. If I rotate, I am an asymmetric body. My rotation makes sense, makes things make sense. So that is why we have 6 coordinates. 6 coordinates, to be precise, 6 coordinates to define my orientation. We call it as x kitna gaya, y, z, 3, 2, 1, theta, phi and psi. So all 6 components, we call it as one vector. I don't know vectors, how many of you know vectors? It's a combination of some numbers. Okay. So in order to specify my position and orientation, I since things are moving, so it also requires velocity information. X में कितनी velocity है, y में कितनी velocity, z में कितनी velocity है. Okay, so two things: position, not only linear positions, angular positions as well, also linear velocities and linear angular velocities as well. How many of you are science background? Somebody raise your hand. Okay, you may be appreciating. Data while going on board. Okay, so the velocities are being measured in non-inertial frames. I'll not talk much. I've segregated it in other format: x, y, z, theta, phi, psi, u, v, w, p, q, r, x, y, z, k, m, n. I've segregated it. Okay. Now based on these, okay, one more thing. I don't know how much you guys can understand the rotation matrix, and this is very important for any 3D object that is moving along in space. We need to connect the rotation rates, the position rates with the actual velocity, which is being connected using rotation matrix. This is way too mathematical, but just keep in mind that if you want to associate your x velocity, y velocity and z velocity with the actual u, v, w, it is being connected through some rotation matrix R. Probably maybe 5 more minutes. I'll not show much mathematics, but I have to show because it's a drone technology course and you guys should know at least these keywords. Okay, rotation matrix will come into picture, and based on this rotation matrix we actually get these 6 kinematical equations, and this is highly non-linear in nature. I don't know non-linear and linear you guys understand or not, but yes, 6 kinematical equations, mathematical equation that drone. Achha, now you have to appreciate this. Every time you make a program, on this computer or this onboard flight controller in order to solve these 6 equations every timestamp. Okay, every timestamp, in order to know what were the orientations at any time. Once you solve this, you will have all the information with x. What is your x? If you solve this with some initial condition, if you solve this, you will have it will start going this way, that way, and any time you will have the information of x, y, z, and theta, phi, psi, and then only you will be able to navigate it with your own will. Okay, why I am doing this? Because I should know the information of x, y, z, theta, phi, psi at every moment. That is the kinematical part, or that is the physics part of it. You should know the x, y, z values from 0, 0, say kahan gaya. Once you know this, you will have the power of navigating this anywhere, and that is why we want to calculate these things. Now, how to calculate? We humans cannot. We are so tiny. नहीं कर सकते हैं. We'll take help. We'll take help from computers. Or this is my onboard computer. The processor is an onboard computer. It computes for you. So where does this computation comes from? I told in the earlier session. Processors. What is the building block of processor? Transistors. Transistors, how do they work? Or building block, or fundamentally it's PNP junctions, diodes. It will work as a yes, no, no, yes. Electrons will come or go or not, it will add or do something. Fundamentally it is semiconductors. And semiconductor allows non-living thing to have a brain or logic. See, from there to computing these equations, bigger equations, and he is doing effortlessly. You need a break. This guy don't want break. कर लेगा, आप देखते रहेंगे. ठीक है. ओके, तो क्या टाइम क्या हो रही है? एनीवन टाइम? 41, maybe 5 more minutes. Now, if you understood this, maybe partially or fully, I don't know, we can jump into this is just one part. No, this is just one part. Now we have to understand the dynamics of it. Now the actual dynamics. Kinematics part is just the relationship. Okay? Now the dynamics part is when you put a force X, Y, Z, now how things are moving in reaction to that. That is the dynamics. Now the dynamics in conjunction with kinematics will give the whole picture, whole dynamical, whole physics of this drone, or the whole whereabout of this drone. Ki this much torque I have given to this rotor and this will move to this way. The whole picture. And that is the actual need. You need to understand this. At least you need to understand why dynamical equations are important to locate this drone from one timestamp to another timestamp. At least you should appreciate this. Why mathematics is important. And that is why it is important. You need to know the mathematics. Okay. Merely just as a put a jack and it is doing some fun things. This is not maths. This is not actually technology. Technology is you actually know the mathematics behind this, and based on this mathematics you can actually propel this drone from one place to another place with accuracy by solving this. Okay. So dynamical equations I don't want to show, but yes, but this is again a bigger thing. I'm going to skip this because Jacobian will come, and I don't know for this class. Control systems will come. Okay, one GIF I want to see. So there is something called PID control action. Okay, which these days it is inbuilt. Okay, or you have to tune it. PID, what it does, let's suppose you want to tell this drone you have to go to 10 feet height and take some picture. So what it will do, it will start going up. So it is covering distance 1, 2, 3, 4, 5, 6, 7, 8, 9. So once it reaches 9, it starts deaccelerating. Since it has to reach 10, it will not keep on going. Okay, it has to deaccelerate after some time. So it may go up and down. So based on the behavior, we can tune this and we can achieve the required performance. Okay. There is a hell lot of things engineering guys are doing. Okay. But yes, at least you should be aware. Okay. Now with this, maybe I could stop here with few takeaways. What are those takeaways at least? First takeaway was every intelligent bot or machine should have 3 components: sensing, processing and respond. ठीक है. Second takeaway, first takeaway is, I told you in the first session, every intelligent bot or machine should have 3 components. It should sense, it should process through brain or maybe microcontrollers, and then respond through actuators or motors, whatever you want to do. So anything that does this thing, we call it as sort of intelligent or maybe robot. Okay. Humans are also like this. We sense, we process, and we respond based on that. That is why we are intelligent. That is the definition of intelligence. Second thing was, रोल पिच एंड यो, वो वाला टेक अवे लेके जाइए. थर्ड टेक अवे is the mathematics behind this drone dynamics. So mathematics is connecting your drone from zero to somewhere. Actually, man, it is the maths that is computing and telling this to go there, not its own. It is the maths behind it. That is the takeaway. Whatever be maths be, obviously you guys are not in that position to understand this maths. I agree, but at least you should keep in mind that there is some maths behind it that this processor needs to compute every time in order to go from one place to this place and then come back, or whatever you do want. There is always a maths, and maths is based on the physical laws. Obviously. Okay, with this, I don't want to go further. Any questions? I want to stop here. अच्छा लगा, नहीं लगा, या ज़्यादा फिलॉसफी हो गई? Am I being too philosophical, or it was good?
It was good.
अच्छा था? Okay, thank you. ठीक है, with this I'll stop here, and maybe you will have a quick test, shall we? बाप रे, small test, है ना? 5 questions. So he will tell, Joshi sir will tell.
Not to grade you.
Not to grade you.
Understand how well you have perceived.
Perceived. Yes.
We can tune ourselves. By no means we are judging you, we are grading.